As I'm done with my most boring meal ever, let's get into how I built Zyro. So, initially, this project started as a voice assisted AI interviewer. I was using 11 Labs. It was fun and all, but I struggled making it affordable, as I couldn't find a cheaper solution for voice models. So, for analogy, it would cost about 14 USD per interview to be profitable in a 1 hour long interview. Crazy. Who's that?
It's me, you dumb fuck.
Kakashi, is that you? I thought you were just an action figure.
Don't think. Just make it a text-based interviewer. It'll be way cheaper.
That's actually a good idea. How come I didn't think of it?
Because you're a dumb fuck. Okay. Bye.
That was a dumb shot. I don't know why did I do that. But anyway, as Kakashi instructed, I went with ChatGPT. Okay, so here's how I designed the system. There are two UI. One, the actual product which users will use, and the other is where I or an admin can set up interview templates and other configurations. We will get into this in a bit. In this user-friendly UI, when a user starts an interview, the request will route to our server and we will generate questions for that interview. And then user will be navigated to another page where the actual interview will take place. And this admin UI can be used to configure stuff like questions if you want to ask specific ones instead of auto-generated questions. And other stuff. We'll get into this as we go. Okay, so I created this basic UI. You can use this to create, say, questions here. You can select the type of the question, add rest of the details, and you can just submit it and a question will be created. You can also create interview categories like front end, back end, or any strange category you want to create. And then you can create interview templates. So basically, this is like a boilerplate for your interview with all the settings and configurations that you can do for a particular category, and this will be used to as a guideline while generating questions for your interview. That's all for the admin UI. I know it's very basic and ugly, but we are the only ones who are gonna see it. And now let's hop on to the main user facing UI. I created a ChatGPT API key and I'm using two different models here. One is GPT 4.1 for the actual rich question generation, and the other is GPT 4.1 mini for conversation because I want it to be faster. When user starts an interview, the user lands in this page. And when the user sends a message here, we hit this API. We run it through GPT 4.1 Nano, and if the user message is not an answer, then we ask the user to stop fucking around. And if it is, then we store it in our DB and proceed to the next question or ask follow-ups. We have one tiny issue though. Okay, a major issue. It lacks memory right now. A good way to handle this would be by dropping every generated message into a message queue. It's just like a pipe that will carry the messages we drop at one end and will be read and stored in our DB at the other end. But again, we have one more tiny issue. I'm broke. How will I pay the price for servers that are always on consuming messages from this queue? That's why I'm gonna use these auto-scaling VMs from fly.io. But this way, I won't be able to use message queues because after certain period of inactivity, these VMs will scale down to 0. Okay, here's what I did. Whenever a message is generated, I'm just adding it to an ordered Redis list. And after sending the response to frontend, I'm asynchronously writing all these messages to my DB. Is this 100% reliable? No, but trade-offs are worth it. Now we need to support coding questions as well. Whenever the next question is a coding question, our backend needs to notify frontend. And typically, I would use WebSocket for this. But you know I'm broke. I can't keep my servers on for a long time. Hence, I'm using Ably. Ably is a platform, that's all I know. Okay, it makes WebSockets simple. Well, I set it up. And now, whenever the next question is a coding question, our server sends a message to our front end via Ably. And whenever this message is received by front end, boom, it appears in the UI. Just like that. Wait, it's not done yet. We need an editor to actually write code. And for that, I came across this editor called Monaco Editor for React, which is built upon VS Code. I added that, and now here we go. We can write our code here, and if I submit it, well, nothing happens. That's because we need to figure out a way to actually run this code and evaluate it. Here's how we will do it. We will store a boilerplate code in S3 with an identifier string so that during runtime we will pop this out and plug in user submitted code here. And along with this, let's save inputs and outputs, as we can have hundreds of test cases, and also these test cases can get fairly large. Storing these in DB wouldn't be efficient. Hence, let's just store it in S3 as files. I have defined input this way. It's not a hard rule, you can define it anyhow you want, but you will just have to parse it appropriately in your boilerplate code. And this output format is nothing but whatever will be logged in the standard output. That means we have to log the final result, and to check if it's correct or not, just this text in the output file is compared with what's logged by your code. Okay, now that we have this out of the way, we just need to evaluate the code. Okay, well, let me complete. We will use Zyro, which you can self-host to, but I will use their hosted free plan. Basically, for each of this input and output, we are creating a submission with output file content as expected output and a callback URL for webhooks. We submit, we receive webhook callbacks, and status gets updated, and our API returns a cumulative result. This is nothing but if all our submissions pass, cumulative result will be success. If not, then failed. And submit, failed. Yeah, this log here is interfering with output comparison, but we can't just disable logs. User needs logs. To put it simply, when we execute a code, we typically have different types of outputs. One is standard output. This is where all the logs are printed, and as this log we added is also printing here, it's conflicting while output evaluation. But if you observe, when an error occurs, we get it in standard error. So what if we direct all the user logs to this standard error and somehow differentiate it so that we can display whatever user logs and it doesn't interfere with the output either? To do this, in the boilerplate code, I'm overwriting console.log with console.error with a wrapping string, so that whenever user logs, it's added to error stream with this wrapping token. And when we actually receive it in callback, we can just separate any part that is wrapped in this and we will show it as user output. That's all. Now we have a proper code editor and submission works like a charm. And then I just tweak the UI a bit, a little bit of salt and pepper, and there you have it. I wanna actually turn it into a SaaS product, but that's for another video. Thanks for watching and smash that subscribe button if you want me to feed Kakashi.